Okay, we are live. So, do we have any questions about this week's stuff yet, or do we just?
I think it was. Yeah, I think it was pretty easy just doing the difference, right?
Yeah, I'm just trying to review it now. I did it over the weekend so that I could have like Memorial Day off. So, but
Yep.
Looking back at it, I think I was good.
Yeah.
Okay, awesome. So let's just.
Okay.
The fun stuff.
Okay.
I'm so glad we're almost halfway done.
Yes.
Crazy.
Did you see the message about a project?
Yes.
What?
Is that it was in the announcements. Is that something we work on together with this group?
I know there is a project, and I believe it is with this group.
Yeah.
But I think it's like throughout the course of the second semester.
Yeah. She just wanted us to get thinking about what we might need to do for that.
I'll have to read that again and maybe talk about it next time. But I'm guessing we're supposed to like study something and do our own testing.
Yeah.
Yeah.
We have to do the first part by week 9.
What week is it? 7?
Yeah.
7.
Okay.
But I think we just have to figure out something, like you were saying, something to study, and then, yeah.
Okay.
Conduct our own statistics.
I hope it's like part of the homework. That it's not on top of it.
Yeah, I don't know. I kind of don't think so.
Oh man, probably not.
Okay, well, sorry I interrupted the quiz.
No, that's okay.
That popped into my head.
If anybody has any ideas, it says, we very rarely use it, but we can use the discussion board where we post our stuff. So if anybody has anything this week, I think that would be a really good place to post it, and maybe just all of us keep a lookout in case somebody wants to post something.
Okay, yeah. Start brainstorming.
Because I know it's like the best ideas come when you're by yourself, not meeting with your group,
Yes.
I'm like, gosh, dang it. But yeah, I think it's really cool because we don't really use our discussion board because we don't have to do it like a typical class, but that's probably the best place for us to do group collaboration when we're not meeting.
Okay.
Sounds good.
Okay. So I have Courtney, Marianne, and me.
All right. Use the following information for the next 2 questions. Suppose we have a set of paired data and let D equal mean after minus the mean before. D is the, I just forgot the word. It's the difference, right? Yes. Okay.
Yeah.
The null hypothesis is blah, blah, 0. The alternative hypothesis is blah, blah, not 0. And the population standard deviation is not known. Jordan collects a sample size of n equals 9 and computes the difference to be, or the sample sample difference to be 2.2 and sample, is that the deviation, SD, right?
Yeah.
Sample deviation equals 2.2. The value of the tested statistic, isn't that 2.2? Because it's like the mean of the difference. The bar of it.
Let's see. Suppose we have set. I have to reread it, sorry.
It's okay. Or maybe we're supposed to actually calculate the test statistics, so we probably plug it into the equation.
That would be my guess.
Yeah, so I'm gonna go find that equation. The difference of the mean plus or minus the t statistic times standard deviation over the sample size. Okay. Now for the t statistic, it's the critical value. Use the table with the n minus 1 degrees of freedom. Let's take a little PowerPoint size. Or maybe that's not the PowerPoint size. I'm just trying to review what we do here because it's not fresh on my mind.
I think we take 2.2 subtract 0, because 0 would be the kind of the hypothesis mean, the population mean.
Mm-hmm.
So that would be the before, and 2.2 would be the after. Does that seem right?
Yeah.
So it would be negative 2.2?
I think it would be positive because you do the after, subtract the before.
Oh, yeah. Okay. So then it's just the,
2.
yeah, 2.2.
We just, okay.
I think, hopefully. I'm gonna have to open my notes.
Are we still checking on number 3 or?
Yeah, sorry, I was just gonna make sure I knew.
Yeah, I don't want to.
Because I thought when we were doing the test statistic, we had to calculate it because that's basically what is t.
Mm-hmm.
So I thought we used the equation of the standard deviation of the difference divided by the sample size. But we don't know what t is in that equation, but that's what we're trying to find out, so I'm kind of confused.
I think that because they gave us the difference mean,
Mm-hmm.
that's what we would use.
Okay.
Okay, I think with the information they gave us, that's what they wanted us to do.
Because I do remember questions like that too, where you think that they're asking more than they are, but they're really just asking for the value you already have.
Okay, should we move on to 4 then?
Sure.
Okay, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. I kind of feel like all of this is really rusty in my mind.
I don't remember them asking those questions in the preparation. I mean, like, okay, if that's the test statistic, then are we supposed to, like, put that into the probability app?
Yeah, that's what I was wondering. Is that the, like, do we use a t-score or the t app? Wait, does it say up here? There it is. If needed, the link for the t app.
Mm-hmm.
So
I need to
maybe
figure out how to download that. Would we type the test statistic into the area or into the z-score?
Let's see.
Because I know how to do all this stuff in the SPSS, but I feel like I get confused every time the homework asks us to do it on our own when everything in the practice was all in the SPSS.
Oh, great. Every single time.
You're just a popular person. So we compare the confidence interval to the p-value, but this is a step before that with the test statistic. And how is the test statistic connected to the p-value? How does it help us find it? I'm just used to taking the data and looking on the little chart in SPSS and then finding the sigma two-tailed.
Let's see. I'm just a little confused just because they only gave us that certain amount of information.
Mm-hmm.
So the probability of obtaining a test statistic greater than Jordan's, like, what are we talking about? Jordan. Jordan's, okay, Jordan collects the sample size.
Wait, is that the answer? Is the p-value 0.0403? Because that's what you'd compare to the confidence interval, right? To see if you fail to reject the null or not.
Oh, so that's the p-value?
Maybe. Because they're not saying it's the test statistic, they're saying it's the probability of obtaining one bigger than his test statistic, and the probability is a p-value number. So I think it's actually just that number, I think.
So, but they're asking us to use this probability to determine the p-value for his hypothesis test. That doesn't make sense to me.
It doesn't to me either. But I think we're on to something. Maybe we're supposed to include his sample size now. Or we plug in that number into the test statistic and do the whole equation.
I'm trying to
Okay.
use like on the horizontal axis.
So, do we use an equation to find out what his...
Do you think we would just take 0.0403 and times it by the sample difference, the sample deviation divided by the square root of the sample mean?
I'm sorry, say it again.
So the equation for the difference, when you're finding the differences, where it's the t statistic times by the sample standard deviation divided by the square root of the sample size. Do we do that because we're comparing his actual sample of 9 people instead of his, what he was comparing it to?
I think I can do that. I'm not 100% sure, but
Can you go louder, Nicole? I can't hear you very well.
sorry. I think I figured it. I think we're supposed to take the probability like what we were talking about and plug it in the graph and plug it into the t and then shade everything to the left of it. Because I'm looking at the book.
Okay.
And it says, if you want to open it or not, whatever. It's just, you take the test statistic and you plug it in to the t, and it says the p-value is the area to the left of the t under the curve.
Okay. Because he's looking for the greater than, so we need to find the less than? Or in this example, are we trying to find the greater than? Because that's what he's... Or do you always do the left?
It just says the left in the book. It's the only reason. But let's see what is it.
0.00403.
Are we looking at the z-score as the answer or the new area?
The new area.
So 0202.
Mhm. Nope, I screwed up. Wait. See? So if we were shading to the left of it,
Are we doing the left or the highest z-score, like shading the middle and the left, or just the far left?
I think it's the middle and the left because it's
Okay.
everything to the left of it.
Got it. So that actually is a lot bigger.
So it's 0.5148. Is that what you guys got? Well,
Yep.
515. That's just what the book says, but I'm not 100%.
Is that 0.9597? What did you get? What's the new area?
Do we need to change the degrees of freedom?
Oh,
What would that even be?
it's the isn't it the mean -1? No, it's the sample size -1, so it's 8.
Let's see. I got
Sorry, you got what?
0.5155.
Oh, I got 0.9841 with the 8 degrees of freedom.
Did you get anything, Marianne?
I'm not really understanding what you guys are doing, and so I've just been trying to read the textbook and trying to figure out, do we find the T-score for Jordan?
So I was looking under the section, let's see. I was looking under step 4 for one sample t-test.
Let's see, step 4.
And it said, if you scroll down a little bit, it finds the t-score. And that's the test statistic, right? And so and if you scroll down a little more, they plugged that into the T in the for illustrated purposes only graph. And then it says on there that they shaded to the left, and you can't really see it because it's so minute. And so then they found the p-value and compared it to the level of significance, and then they used the, if the p-value is small, then you're definitely off.
Okay. Let's see if I can enter in some numbers.
Yeah, I just found something like that too in my notes. That kind of goes along with the T.
And the degree of freedom is 8 because you take the what was it? The mean?
The sample size.
Size minus 1.
So did you get I tried entering in the 2.2. I tried doing a T distribution, a T score thing.
I don't think we're using the equation. We're just using the applet.
Oh, okay.
We just used the test statistic as the T.
And we're shading to the right because it was greater.
That's what I was trying to figure out because the book says always to the left, but I don't know if that's because. Okay. Only the left tail is shaded even though we cannot see it. And then this one, and it might be because. Ugh, I'm so confused. Okay. Okay, this one's left-tailed, so they shade to the left. But what if it's double-tailed?
Do not shade the middle and shade the two ends.
That's what I'm thinking.
And then it's a not, the null is not equal to 0, so that means we don't have to divide by 2 or anything.
Right. Is that how you got yours, Courtney?
Huh?
Is that how you got your number? The 9 point or
Oh,
0?
well, I just unselected the middle now and selected the right side and left because of what she said, so I don't have that answer anymore.
Okay.
I have 0.0318.
Point 0.9691.
Okay, so the original one is 0.0403, right? With 8 degrees of freedom.
Yeah.
Okay. Well, then the t statistic for that is negative 2.44, right? If you type that in with the two wings selected.
Oh, that's why. Okay. So it's negative. How did you
I
get?
don't know if we use the t statistic there. We're trying to find the p-value, not the t statistic of his hypothesis test. But I don't. And then maybe we use that number to plug into the equation that Marianne was saying.
What I got was 2, which then just made the area.
Well, I'm wondering if
0403.
okay.
0.0403.
I'm wondering if we take that area, stick it into the probability app, highlight the two sides because it's a not equal to alternative hypothesis.
Mm-hmm.
So do the right side and the left side, find that z-score or that t-score because it says t equals. Take that 2.44, plug that into the equation. Do you think that might make any sense?
Yeah.
We have the t and we have all the other information we need to fill out that equation.
So this is these
So it'd be like
probabilities.
I'm just super confused, to be honest.
2.44 times the sample standard deviation, which is 3.3, divided by the sample size of 9 square rooted is 2.684.
I don't know.
As a I'm not sure either. It might just be the area that they're asking for because the probability should usually be less than 1, right?
I wonder if it's just as simple as what I have is you have the 8 degrees of freedom, and then you have the area as 0.040. What was it?
3.
0403. And then you have that right side highlighted for the area, but then you highlight the left side as well because it's a two-tailed test, which would then give you an area of 0.0805 because that's what he's trying to figure out.
But my area still says it's 0.0403 for highlighting that.
For both of them?
Yeah, I don't know why. Like if I just highlight the two and the areas I put in was 0.0403. Do I need to put like highlight the tails and then type that in?
Yeah, I think so. Oh wait, I think you'd highlight just the one tail and then enter the area in and then add in the second tail. I don't know, that's my guess. That's what I was getting.
So you got 0.0806.
Yeah. So it would be 0.081.
Maybe. I don't know how much farther we're going to get on that question.
Yeah.
I think we better just ask for help.
Yeah.
We get it right, cool, but
Due tonight, so if we turn in this test, we can still, if we figure it out by tonight,
yeah.
with the teacher helping, then we can retake it. Okay, is it my turn?
Yeah.
I think that was mine. I did that one.
Oh, so I think
Kind
it's
of.
Nicole's.
Yeah, okay, sorry. Use the data file to answer the next 6 questions. Perform a paired samples t-test and ST-test. Be sure the test does group 1 minus group 2. Use a null hypothesis of that and an alternate hypothesis of that and level significance of point.
Okay.
So we need to make a sample first. I mean the difference first, right?
Which file was it?
The first one,
V1.
Chapter A1. Okay. I have to open it in the textbook on
oh yeah.
remote.
So we have to compute the variable. That'll let the difference. And is this going to be group 2 minus group 1? Be sure the test is group 1 minus group 2. Just kidding. Okay, it says that.
Yeah, group 1 minus group 2. Of course, everything's like crashing. I'll get you one.
Sorry, I'm still waiting for mine to open up.
Mine keeps telling me I have an incorrect name and I'm supposed to spell out minus.
Okay. So now that I have it open, what am I supposed to do with it?
Well, we got to compute the variable. So you got to transform, compute variable, because we're supposed to make sure that we're doing it for the two together, the difference.
Mm-hmm.
And then we do group 1 minus group 2.
Oh, see. So it's group 1 minus group 2. That's what I was
In
wondering.
this case. Yeah, except for it's not telling me that I don't know if I'm typing it incorrectly. Like I'm getting rid of spaces, changing things that keep saying incorrect. Variable name. Even though I'm typing group 1. Am I not supposed to use capitals? I'm trying to type it exactly how it looks in the data. Oh, there's an underscore. That's why. Got it.
Mine is just not working.
Your SPSS isn't working.
Yeah.
Okay, so group 1 minus Group. Group 2.
Okay, so I have the difference now. You might have to go off ours, Nicole.
Yeah, I'm sorry, you guys.
You can visualize in your head.
Okay, so now I've got the difference column.
Okay, I want to make sure our numbers are like the same. Is your first one negative 32.10
Yes.
and then 35.30?
Yep.
Okay, so we should be on the right track. So we're finding out what's the test statistic. So don't we just go to compare mean, analyze compare means, one sample t-test, and do it for the difference. What do we type in for test value? I got
I think
the null, so it's 0.
0, right.
Okay, so I got 0.407.
Yeah, that's what I got. 0.407.
And the p-value, and this is it's a two-tailed test, so we don't have to divide it at all.
So number 5's answer would be 0.407, right?
With the 0 in front.
Yeah.
0.407.
The p-value is
Sigma two-tailed is 0.689.
scroll down. 0.689, yes.
Okay, we're comparing this to 0.10. So it is larger than that, so we failed to reject the null.
Okay.
So we fail.
Yeah,
Yeah.
it's 0.689 compared to 0.10.
Okay. Just making sure.
Question 8. Suppose your alternative hypothesis is greater than.
Oh, then we would divide that by 2.
Okay.
I don't know if that helps us find the answer, but
Yeah.
I mean, it's still larger than it.
So
I think it's C. We have sufficient evidence that the mean of the difference is greater than 0 because it still can't fail to reject it.
wouldn't it be the insufficient one? Because then it would be a fail to reject.
But the mean we're finding is greater than 0. And it's greater than the confidence interval. So I feel like that makes it strong evidence. I don't know.
I thought that if you were going to say we have sufficient evidence that you would be rejecting the null.
Well, you can have sufficient evidence that you can't reject it too, and sufficient evidence that you can. Right?
I think so. Because I thought insufficient evidence just meant we didn't have. Well, sure.
So it has, we have sufficient evidence that the mean of the difference is greater than 0.
I'd say so because our number is a lot greater than it, and that's our evidence, right?
Well, I kind of still think it's the second one, but
What do you think, Nicole?
No.
We're a house divided right now.
I'm Switzerland. I don't know.
Okay, I'm gonna look in my notes for this one then for a minute.
Or you can do that one and I'll do this one and we'll see which one gets it right.
That I want to see if I understand it before we choose that.
Yeah.
That might be what it comes down to. Hmm. Because if, I don't know, I have a little asterisk that says if 0 falls between the confidence interval, then you can't tell if there is a mean difference. So that would, to me, seem that you'd have insufficient evidence if it fell into the interval versus out of it. So I think we have sufficient evidence because it fell out of it. But that's not a huge, great source to go off of, but I do have that written down. I guess I'm talking about the confidence interval there. So just kidding. Maybe we're supposed to look at the confidence interval because on the SPSS, because if 0 falls into the confidence interval, then we can't tell if there is a difference, a big enough difference. Does that make sense? And in this case, 0 does fall because there's a negative and a positive. Well, we can see who gets it right.
Okay.
And move on. Okay, use the data file, the other one, to answer the next 8 questions. Perform a paired sample t-test in SPSS. Be sure that the test does group 1 minus group 2. This data comes from that. The null hypothesis is equal to 0, and the alternative hypothesis is not equal to 0. And the level of significance is 0.01.
Okay.
So we gotta set this up.
And I have no help. I'm so sorry.
So
how does this one wind up? Is it still group 1 minus group 2?
Yeah. This question 9, is N or the DF greater? Wouldn't always be N because
Because that's always, it's N minus 1, right?
yeah.
Oh, sorry, I'm not there yet. Okay. Is your difference start with 39, then 22, then 25?
Let's take a look. It says yes.
Okay.
39, 22, 25.
And you're right, N would be greater because it's N minus 1 is how you find the degrees of freedom. So 9 is N. Okay, what is the p-value? So we're going to analyze, compare means, one sample to test. Okay, I got the p-value as 0.001.
Let's see.
And it's still not equal to 0, so we don't divide it by 2.
Let's see. I'm trying to figure out where my information is. There's so many things that are open.
I know. I wish I had like 2 computer screens when I do this.
Me too. Okay, so my output, did I actually calculate this? I don't know if I did. I thought I did. Okay. Let me calculate it then if I didn't. I'm sorry, I thought I had calculated it, but I hadn't. Okay, so the 001 is the 2 tails.
Yeah. So that means it is smaller than the alpha, so we actually reject the null, right?
Yeah. It's rare that we get that answer.
I know.
It's okay.
Okay, I think it's Nicole's turn.
Yes. Okay. You decide to try another alternative hypothesis. This time you use that. And you keep the same level of significance. Did the p-value increase or decrease?
We're just dividing it, which of course is going to decrease if you divide it by 2.
So what decision do you? Oh, sorry, that was not my turn. It was just.
Huh?
Sorry, I kept reading because it just. I
Well, I
read.
think the next question just goes with it, so go ahead.
Okay. What decision do you make?
So we still reject it.
It's even smaller.
Are you still with us, Marianne?
Yes. Yes.
I'm feeling better now. Like, we're not going to completely fail this quiz because it wasn't a good start.
No, the second question we were like, oh no.
Yeah, really threw us.
And I feel like those are supposed to be the easiest ones. And we must have
Yeah.
like overthinking.
Really shook my foundation.
Okay. I think it's Marianne's turn.
Okay, based on your response from the previous question, what conclusion do you make? So this one I'd say we have sufficient evidence that there is a mean difference between the two groups.
But there's no mean difference, right? Because we rejected the null. Yeah.
Yeah.
Okay. Yeah, so the third one.
Yeah, the third one.
Okay. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give you the smallest p-value? Well, it should be probably the mean is less than 0. It has to be at least a less than, though. But couldn't it be both? Well, it should be less than, because then that would be even smaller than 0.
Well, think about the last problem we just did. We always, we were talking about how we very rarely get that answer, and that was a less than.
Yeah. There you go. I feel like if it's greater than, the mean is going to be bigger than 0, so it's more likely to be bigger.
Yeah.
Okay. Did I read that one?
Yeah.
Okay. Yeah, so Marianne, right?
Okay. Determine the 95% confidence interval for the mean difference between the two groups. I just remembered something. Were we supposed to change something with this last group because it had a 0.01 level? What is it called?
Confidence interval?
Yeah.
I'm going to go back in. I don't think so, Well, yeah, actually there is a confidence interval percentage and it's set as 95% usually.
That's normally 0.05.
So you're probably right. So now we need to go back. What is 0.01 equal to again? Is that 99?
I think that's what we did before, yeah. I need to write those down.
I think our answers are still the same though.
Hi.
Still 0.001.
Yeah, looks like it is.
Phew.
Still a good catch.
Okay,
So now
so
we switch it back to 95%.
yeah, then we are doing 95%.
Okay. Okay. And it wants to know what the point estimate is. Is that the T?
What is the point estimate?
Nice.
Is that T? What's the point estimate?
I think so.
Okay, I think so too.
Point estimate. Those are point estimators. It's like the mean, the standard deviation, variance.
Mm-hmm.
Would that be the mean then?
Huh?
Would
Yeah.
it be the mean or?
No, I think it's okay. What did you say it was again in your reading?
It's the point that estimates the parameter. So the mean, the sample mean, like the sample statistics.
Yeah, but you could choose several, right? So is the point estimate supposed to be a specific one?
Or this confidence interval.
I feel like this is in my previous notes more. I'm gonna look that up. Because that's the test statistic, but not necessarily the point estimate.
Mm-hmm. So I kind of would guess it would be the mean, but I'm not sure. Or 95%.
Well, that is the main point that we're going off of, right? Because everything we're trying to find that the mean is close to the old mean in most studies.
So is that 11.955?
11.955, yeah. And I got distracted a little by some other notes that might answer a previous question we were confused on, so I'm just reading that real quick. Because I just found a note from lesson 11 that says the p-value, and that question that we were really confused on at the beginning.
Mm-hmm.
And this is kind of what Nicole was saying with the probability app. I think question 4. Yeah, that's the one you're confused on. Says the p-value is the area and the two tails beyond the test statistic t. In other words, the p-value Well, then it talks about how it's equal to sig two-tailed. So I wonder if we are supposed to actually plug in that test statistic into the bottom and not into the area. Because that's where t equals is. Like in the z-score spot.
But the number was a probability.
I'm going to read that question again. Okay, that's what gets confusing. So then that would be why we put it in the area. And then we took the t-scores and you do everything to the left. That's because the example though here, they will show that the means are to the left. So in our case, we would have done both sides, and that's what we did. So I guess we are still on the right track with that. Okay. I wanted to check on that again. Okay, who's on number 17?
I think so, yes.
Yeah.
So this one we're calculating the margin of error.
Mm-hmm. And I don't really know how to do this one. Margin of error has been confusing me lately.
It's where you take the 95%, which is what, 1.96 times the deviation over the number square rooted.
Okay.
So
That's kind of what I thought. And then the sample size here is what, 22?
to look.
Yeah.
Yeah.
Okay. What was the deviation again? I gotta scroll up.
Is that 15.003?
Oh, it's over here, yeah. Yep. I don't think we're supposed to round until after though, so I think we add in the 1, 0, 2.
Okay.
Okay, so then it would be 6.270 rounded.
6.270, yeah.
No, 269, because 3 doesn't round it up. Right, 6.269?
Oh, yeah, sorry.
Yeah,
I
3
guess
is
I should
90.
look closer.
What did we put at 16 again? I forgot to type it out.
What'd you say, Nicole?
What did we get for 16? I forgot to type it.
11.955.
Sorry.
Okay.
Okay.
Input the lower bound.
Okay, so we have to get the
5.3025. Do we use that one, or do we have to like recalculate again or anything on the other way?
I think I need to use I need to go into Explore.
What do you mean explore? Oh, analyze description.
Yeah.
Yeah, okay. Because I get confused on that. Sometimes they don't want you to use the one in here. And this is for 95%?
Yes, I think so. So
It's still the same answer.
is it?
Yeah, that's what I found out in the homework last time too. And so I just get confused on what we're supposed to use or not. And I figure this is the safest one, is the Explorer version.
Yeah.
On the other equation, you're supposed to use that one.
Okay. So the lower bound is 5.303.
Mm-hmm. The upper bound is, okay, go away. It's an 18.607.
Yes.
Okay. Well,
Here we go.
I'm gonna
Are we
grab a
ready?
sticky note so I make sure I write the ones we got wrong, and then I know which ones I need to ask about. So I'm submitting it now.
Okay.
Okay, did you get question 8 right? Because I got it wrong, so you might have been right.
Let's see. I got it right.
Okay, so it was insufficient. Can you explain that again? Why you feel like it was insufficient? I'm trying to wrap my head around it.
I think it's just when I have a really simple brain, and so I just noticed in the reading that every time something is failed to reject, you say it's insufficient evidence, and when it's reject the null, you say you have sufficient evidence.
Okay.
That's my only explanation.
I will take that though. I like simple.
You guys get 15 and 17 wrong?
Let me take a look. I'm still looking through.
Sorry.
Yeah.
For 15, I went and changed it, my answer, because I just kind of felt like maybe it was actually not enough information. So
Yeah.
I got it right.
Oh, okay.
So it's not enough information.
Because yeah, you don't always know.
17 I got wrong as well.
Why did we get that one wrong?
So that was
This quiz is making me feel less confident.
Like I was confident on the preparation.
Yeah, me too.
And then did you guys get number 3 wrong?
Let's see, number
What is the
3.
value of the test statistic?
Yes, I got that one wrong too.
Okay, so we were confused on that, and apparently we still don't know. So maybe we were supposed to plug it into an equation, but we didn't know what the t is because we didn't know the confidence interval.
Yeah. I don't know.
Yeah, I don't know.
Well, 80% is not the most terrible thing, and at least I can go get a few more questions.
Yeah. With those extra questions, I got 90%, so that's all right.
Yeah, it's not terrible. It's just I'm worried about having those kinds of questions again.
Right.
Learning them.
Maybe we could send her a message and ask her to explain some of those.
Do you want to email her and like maybe
Uh-huh.
tag us, like put our emails into it too?
Okay.
And just have her explain 3 and 4.
Number 3 and 4.
Yeah, for sure.
And also 17?
Yeah, because we don't know what happened there either. Right.
Okay.
Okay. And then that way we'll all see it and you don't have to worry about forwarding it.
Was it number 4 that you were wondering about?
3, 4, and 17.
Okay.
Except for we got 4 right. Amazingly, but
I'd like to know exactly how.
yeah,
Yeah.
me too. Just because it confused us so much, I'd like to hear her explanation.
Okay.
So, yeah, then I would feel better.
I will do that then.
Okay.
She should get back sometime before tonight. Okay, sounds like a plan.
Thanks. And next time, let's see, that is Thursday. Who should lead? It's
Nicole did it today. Didn't you do it last time? So is it back to me?
yeah.
Because they're kind of cutting Maddie some slack with being almost due.
Yeah.
Okay.
Okay.
Sounds like a plan.
Thanks.
See you guys then.
Thanks. Good luck.
Bye.
Bye.